We're asked to solve the equation x squared plus 5x plus 2 equals 0. We can try to factor this, but we're not going to have any success. And after giving it a little bit of a try, we become pretty sure that it's not going to work. We can't get anywhere close to the 5x that we need here using any integer factors of 2. So we test the discriminant, the b squared minus 4ac that you get in the quadratic formula, and you know that you have to take the square root of that, and that's going to contribute to the value of the zeros, which correspond to factors. Okay, so b squared minus 4ac, in this case, a is 1, b is 5, c is 2, so we easily substitute, and we get 25 minus 8, that's 17, and the square root of 17 isn't an integer, which means we're not going to have any integer solutions, which means we're not going to have integer factors, where we have binomials with integer coefficients. Okay, so this doesn't work. So we have to use the quadratic formula. And we've already got a head start. We've already got the square root of b squared minus ac. We know that's 17. So we write down the quadratic formula, negative b plus or minus the square root of b squared minus 4ac. All that divided by 2a. b is 5, so negative b is negative 5. B squared minus 4ac, we calculated up here, it's 17. And a is 1, so 2a is 2. And we simply write this as negative 5 halves plus square root of 17 over 2, that takes care of the plus, or negative 5 halves, get the same thing there, minus the square root of 17 over 2. Our solution set is therefore negative 5 plus the square root of 17 over 2, negative 5 minus the square root of 17 over 2. For this quadratic, we could use the quadratic formula, but this one factors rather easily into x minus 7 times x plus 1, giving us these two factors can't be 0 unless one of them is 0. So either x minus 7 is 0 or x plus 1 is 0. And if either factor is 0, of course, when we multiply them, we do get 0. So these will be our solutions. And this corresponds to x equals 7. This x equals negative 1. Very obvious solution to each of these equations here and here. So our solution set is 7, negative 1. Okay. Now, I think I'm in order here. The next one is x squared plus 4x plus 6 equals 0. Well, b squared minus 4ac is 4 squared minus 24, which is negative 8. Now, this at first looked like it might be factorable because we have easy factors of 6, but they don't work out for 4. And in fact, 6 is just too big. Anything that we do to factor 6 is going to give us a number bigger than 4 here. The quadratic formula gives us a negative, the discriminant, the square root thing that we evaluate in the quadratic formula. We're going to have to take a square root of the negative, and that's not a real number. Well, I'm going to go ahead and do that because everybody's seen this. It's just probably been a while, so we might need a little bit of refreshing. This might need to be refreshed a bit. Okay. We plug the numbers into the quadratic formula. Of course, the coefficients are a is 1, b is 4, c is 6. The b squared minus 4ac is minus 8. We've already got that, so we'll put that under the square root. We've got a minus 4 for b and a 1 for a, which gives us 2. 2a gives us 2. Okay? Now, that's what we would say. This is not real. There's no real solution. For the purposes of what we've done up to today, we've just been dealing with real numbers. That's the end of it. There's no real solution. But very shortly, we're going to get into complex solutions. So there is a complex solution. The negative 8 can be written as 8 times negative 1. So we can factor negative 8 into 8 and negative 1. And of course, the square root of 8 times negative 1 is the square root of 8 times the square root of negative 1. And then the square root of negative 1, and you should be familiar with this, it's I. I stands for the imaginary number. I equals the square root of negative 1. And maybe I should write this in here. It's not a real number because there's no real number whose square is equal to -1. So we call that an imaginary number. And these things are incredibly useful in ways that you probably won't deal with very often, but they are incredibly useful, and we want to include them here so that our algebra is kind of complete. So we got the square root of 8 times the square root of -1. Square root of -1 we call I, so this becomes the square root of 8 times I. So we have -4 plus or minus square root of 8I over 2. We distribute the 1/2, the multiplication by 1/2, or the division by 2 over the additions and subtractions, and we get -2 plus or minus the square root of 8 over 2 times I. We can do a little bit more with this. The square root of 8 can be written as the square root of 4 times the square root of 2. And the advantage to that is the square root of 4 equals 2, so that when we're going to have 2 divided by 2, which is just going to leave us square root of 2 here on the I. So we end up with -2, which we already had, plus or minus, dividing these two, the square root of 2 times I. Okay, one last quadratic equation. And these were quiz problems. 2x squared equals -12x, -12 minus 10x. Now, I didn't tell you in the test that this was a quadratic equation, and I'll often see people trying to divide both sides by x, or doing all kinds of things that aren't going to work. You have to identify this as a quadratic equation before you can do anything sensible with it. So we have 2x squared equals -12 minus 10x. How is that a quadratic equation? Well, we just add 12 plus 10x to both sides. We're going to get 0 on this side. We're going to get 10x plus 12 on this side. And right here, we easily identify this as a quadratic equation in standard form with a equal to 2, b equal to 10, c equal to 12. Now, we could easily plug those values of a, excuse me, b and c into the quadratic formula, but there's actually a simpler thing we can do. We can divide by 2 and simplify these coefficients. The numbers get smaller, and we have a 1 in front of the x squared, and that just makes it a little bit easier. It's not going to change our solution. We get the same thing, but actually having done that, it's very easy to see if this thing factors, so we don't even need to plug into the quadratic formula. Now, you might or might not have been able to see that this factors, but of course factoring is the first thing you want to think about. And it's not that difficult to see the factors here, but it's much easier to see them here after you divide out the 2. Okay, so this becomes x plus 3 times x plus 2 equals 0. The result that either x plus 3 equals 0 or x plus 2 equals 0, etc., the usual reasoning. And our solution set then is the set -3, -2.